go ahead, man. You go first.
Yeah, I did, dude. Thanks for your advice. All right, guys. Modern technology. Gonna sit here for all day and give you guys a lecture with bullshit thing. Just kidding. All right, so we're gonna do the modern technology today. I'm talking about I'm doing research about come on. Yeah, it's work. I'm doing research about the biology printing. So this 3D print organ that the last week I mentioned about. Long times ago, I go to biology class, and I know biology mean life. Logy that means study of life. A printer can print live, so organ, living tissue, any kind of your body part. So lucky, for everyone that waiting list for the organ transplant. Right now, they just have the tissue of the patient and then print it. I know. Theory. So this is one of a printer. So this is an ear. They print the liquid though. The liquid they call the gel, biogel. So make the cell living. So a print structure is print small vessel. They can print small vessel, detail of organ. If you have the detail of the heart, they can print the heart. Like they have a 3D print on the next door there. They print everything, the most is everything, structure by structure. Pretty cool. So you see that the kidney, I don't know, kidney or something. Yes, kidney something. So bioink and biogel. So the bioink is a biomaterial composed of a living cell to create a 3D structure. The biogels is extracellulose matrix fluid gel support the cells. So everything that they are printing is have to be evolved with the software of the developer need to create a software to make a print. What do you need? The main process you need blueprint, 3D organ. A printer will dispense bio and biogel to shape an organ. So the bio ink is printing the organ, the biogel support the organ life. So the dispensary is gonna bio ink or hydrogel repeatedly until the many layers are formed. So what can the 3D do? It successfully print the blood vessel on the past, bone, skull, I don't know what word is. Can you spell that, John? The tracture raft, right?
Tracheal?
Yeah, tracker raft. So 2014, Bond view we and collaborator at the Utrecht Medical Center able to replace complete the skull. They print the skull though, pretty cool. So I mean the first, I mean can't go back, yeah. So that basically is a biology that can use every kind of they use a computer to control the system. They can dispensary the cell and every kind of stuff. And in right now a lot of people waiting in list. Like I can estimate like over like 15% of people waiting in list for the organ transplant. And the last 2015 they waiting in list, but they can't transplant and they die. But now you don't need to some of them, the rich person, they can buy on the black market on Chinese organ, they can transplant it. But now you don't need it. They're gonna print to you the organ. The second article that I do is a smart car. You can see a lot of feature on the car right now. They can automatic stop whenever you go for, like, you can set the speed of the car. They will follow the front of the car until they can't follow anything in the front of the car. But if the front car stops, your car is supposed to be stopped with the new technique right now. Um, so the Tesla, they claim that right now they can fully drive with the smart car. Fully, you don't need to touch your hand in it. It's just sitting there and chill, read audio book, um, you know, watching movie. They stop you in the whenever you want. Meeting, playing chess. But actually, this is dangerous though. You're dead and you don't even know why you die because you don't trust technology. The smart car, they combines with a lot of sensor surrounding the car. With they have a camera on the front. They have the camera on the front and two camera on the side of the car. Even though they have a sensor on the top of the car, they keep track of the road. And in the article that I read, though, they don't talk much about the car working, how it's working. But I read another article that say it working by the sensor and navigation. But in the problem, they have a six step they call zero, no automation. So you have to drive by yourself. Driver assistance, so the human drive with the fallback, executive steering. You have to do anything at the human. And the second thing is partial drive is you have to do everything a system do for you, but the monitoring driving environment is have to be human drive, and fallback performance of dynamic driving test is the human drive. The automate driving system monitoring driving environments. They have the third, they call conditional automation driving. Everything is system, but the fallback performance or dynamic driving tests have to be a human driver. The four, they call the high automation stack. It means system. Everything is system, but the system capability driving model is a somewhat model. So that is back on the couple years ago, the Tesla test about the self-driving car. It got accident a lot. So they just as a high or the conditional automation. So now the Tesla claim that they fully automation. What if fully automation is a full-time performance automation driving system of all aspect dynamic driving test. Everything is system control. That basically they build a car and then you just sitting there, tap your address, boom. You don't need to do anything. You go there. And parking itself, I think the car will be fine the spot to parking itself. And then they will, whenever you're done for your job, just press remote control or anything on an app, the car will come to pick you up. Convenient, right? The third is a virtual reality for the blind people. So they call it Canecontroller. Pretty cool. Actually, a pretty cool VR virtual reality to help people. So as you can see the picture of the people, they have a crane. The crane is have the brake itself, slider, tracker, voice coil, controller. So they are everything on the virtual reality testing right now. It's physical feedback brake mechanism. It's make apply people get into the wall. They help the blind people to stop it and pull people back. So vibrate tactile is a vibration, so this will vibrate, if you hit the target or you hit some object on the road. Spatial, 3D auto, the sound. So it's will be yell at you or the object on the front.
But they can't see anything.
Yes.
So they just happen to be using a headset because it has the tracking?
Yes, they have the tow-by tracking on the front of the Vive.
That was the way to get that equipment on them. It's not like, okay.
Yes, they just get the equipment on them, but
they're getting all sorts of feedback from these other things, sensory and vibrations.
Yes. Okay. So the companies is I don't remember the name those, but whoever researched the paper, but the last one I don't know, but the last thing that I read it, the company will be spend the money on this project and make with the convenient classes with the augmented reality. So basically, you have a class, you're wearing a class, and then they have all sensor. You don't need to wear the heavy helmet, go around. So the crane, it have to be the same option with what they have on the picture. So the mechanism, they will hold you back like you cross the street, and possibly on the sensor on the front, they can see the red light or something and stop you and pull you back. You have to stop like that. So the crane, they claim on the article, they claim the auto arms auto work, automatically complete arm and working task environment. So they just like a smart crane. They can get you into the, if they put some navigation system on it, it will get you into the right place that you want to go. They use some sound reflect object localized called echolocation. It's kind of audio feedback when they hit the object, and feedback is to the sensor. So the Canecontroller is help people navigate in real world virtual environment with the feedback. That is the article that I read. They have a lot of thing like controller on the crane control. They call shorelining or something, and audio touring. But the project is still on the implementation. So it's in the future. I guess they're gonna have plenty of object, pretty convenient. You put it on your eye and stuff, and you're done with it.
That Canecontroller thing, is that something that's only for the VR? But it says navigating real world, so is the idea that they could take that out in public?
Yes, they can take that out.
Like a smart cane?
Yes.
So it's giving them additional feedback. Then I don't know.
It's
traditional. They're tapping. And
yes,
stuff, and
it's claiming auto work, auto arming. So they automatically arm to oh, it's rock is here, it's arming rock. Oh, I know the rock's here.
I see.
So the class for applied person, this basically pretty impressing me about the classes for automation. I trying to do a lot of research. They don't have a class for the applied person to see what they see, but in the medical last year when I read the article, they have successfully make the applied person can see the real world. But this object is pretty cool though. The sensor, the class, we send signal to capture the image, but the image is pretty much you cannot capture the image and turn into the word that you want. They capture, but they can't do it right now with printing ink or something. So the camera capture image, detect the objects, extract the text region, and turn into the text by binarization recognize, and the output to the blind person, the audio will read the text to the blind person. So that option is pretty cool though. They have I read it in here. They can read the most of everything with you have to checking the object in front of your camera, so they will detect the text message. They have the thing is the S equal to 1 divided by V pi, and I don't know what that's called. John, you math person?
Sigma?
Yeah, sigma. Yeah, sickness for me. So the V denote the I square TX frame. Then the V denote the number of frame. The B denote the estimate background from a motion of the object. So the objects have to be moving in front of the camera. So R it represent the calculate for route object is frame. So it will capture every frame of the picture, and then the novel processes text localization algorithm is applied into the objects. Extract the text region. When it extracts the text region, it denotes the subtability response of the text layout on the X denote. The axis is denote candidate text region from the object's interest S. So they have all the function here to apply into the classes. For me, it's all about technologies right now. It can be happen with anything, even if you apply. Last year, I read the article though. They say one patient that can see the light with the camera support. They surgery on the brain or something, and then they have a system and stuff that you can see that by camera. You cannot see by the eye because they blind. With all those technology, I guess my idea paper next week. I'll do the anything is about VR. Hopefully, I'll do the driving with the VR, possibly. The 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 thing is you can sit on a car, you're driving in the real world, real everything with the VR Oculus or something.
You're in the car wearing a VR headset,
Yeah.
driving the car.
Yes. By
what's that supposed to, like? What are you solving?
the thing is you sitting on the car, but this is test on the feature though. But when you sitting on the car, you driving itself by your headset with the controller. And later then I know the automatic self driving pretty good right now, but people still having accident. But whenever you test it on the VR, you bring it to real life. It's more safe there right now. If you test it outside, I'll make the projects is everything is on the VR. Everything is on the VR, and you can test it real life on the VR. Even though sensor and stuff, everything at the corner of the road, then the car will automatic drive. Turn right, turn left, and what you want to do. Like, okay, you want to turn left, click it on one button, turn left. But on the real life though, they test the car as not safety at all. Like the automatic self-driving is still going off road of the passion road, so they hit the people on the sign. On California, they claim that the lots of trouble on the self-driving car, hitting accident, can see the another curve from the cross sign. So it's basically when it go, see the red light stop, blue light go, but they don't see the right side. When green light go, the car is boom, and it's hard to detect the stop light. So basically, my research is next week. I want to do anything automated driving on the VR, or if I couldn't find any resource on our automated driving on a VR, I can do. I'll continue the the project of a blind person on VR. So basically, I have two idea projects on next week. There's the car fully driving on the VR, and the support blind person for the VR. So basically, you have a class, you can turn it into something, because I think right now the sensor of they implant it to your brain and then make you see the world, but through the camera. But I want to make something like the blind people can be purchased and walking on the road without wearing the class. Like they have a class, they can basically see the object and then purchases something of device that they want to purchase. They don't need to draw out the credit card or something to oh, it's my credit card. It's not safety for them to use a credit card. They're gonna get stolen, stole credit card or something on the future, and they cannot check the bank though. The objects of mine in the future, it's all about helping a blind person to accomplish the goal that easy for them to
So some way for them to navigate the real world. And
Yeah.
then bringing in like biometrics.
Yes.
For them to be able to do things securely without possibly like exposing their wallet or something like
Yeah.
that to other people who might just grab their stuff. So
Of course.
kind of the idea of like Google Pay or Apple Pay or something like that, but something with their biometrics, whether it's their voice, whether it's a thumbprint, whatever it is.
Yes,
but
correct.
some collaboration between move through the world through audio and stuff like that, and then be able to interact with the world
Yes.
closer to what somebody who does have their sight can do.
Yeah. So it's more convenient for a blind person. They don't need to purchase an expensive class or go to do the expensive implant and stuff.
Well, realistically, I mean, I think if you had a good solution, if it was expensive, that would be okay.
Well, what about the poor person?
Well, no, I get it, but it's got to start with something.
Yeah.
And even if it's expensive, that doesn't mean don't do it. If it's a good solution that just happens to be an expensive solution, I think there's going to be plenty of GoFundMes and stuff like that might make it available to people with blindness.
Yeah.
I think the least important part of it is the dollar cost of it. If the technology can actually help, then you figure out ways of making it cheaper, or insurance will end up covering it.
Yeah.
That kind of stuff.
So that is all my presentation. Any question about it?
Oh, some cool stuff.
Good?
Good.
You gonna go next, Jonathan? Oh, not you. Don't look at me.
Yeah. I was just gonna open my chips.
You can check them up when you need them up there.
No, it's okay.
Yeah.
We're keeping it informal.
All right.
Abstraction. You don't have any other name?
No, it's pretty straightforward. All right. So since this week was based on abstraction, I named my presentation Abstraction. Gets right to the point. All right. So the first article I had and I looked at was a simple computer-aided three-dimensional molecular modeling for the Octant rule. If the Octant rule doesn't make sense, it's also referred to as the octet rule. Same thing. All right, so essentially what they did, this guy did, was he looked at how we use the octet rule now and looking at it, and how we typically do it is by creating physical models of molecules and looking at them and counting in the regions that they have there, whether that be by drawing it, which isn't the best way, or making it with like pieces of cardboard, plastic, foam, things like that, and then counting like your electrons and things like that. So his way to do it was actually using 3 different programs. PowerPoint, ChemDraw, and Chem3D. He used a combination of those programs where it was quite a long process, but essentially he simplified it down to that you wouldn't have to necessarily like build something or draw something out and then count in order to reach your final solution. He was able to do it automated with the computer. So he simplified the process so that you could do it for multiple molecules a lot quicker. Essentially, the software implementation was a more abstract way of doing it. All right. This next one was we took a simple computer-assisted quantification of contrast in a fingerprint. So the contrast of a fingerprint was quantified using a simple method. They found the mean difference of pixels intensity between the valleys and the ridges of the fingerprint. So they had actually two different ways they did this. They used an aluminum powder preserved with the gelatin lifter, as well as an inked version, standard inked version. Like, you know, you take your thumbprint, put it down on paper, and then they took pictures of with different types of cameras at different resolutions, and they were able to determine or quantify these results. So what they did was they actually took it at different resolutions of 200, 400, 800, and 1200. And the DPI is like dots per inch, so essentially that's the resolution. And this, let's see where we go. So they found the average intensity of the pixels within the photo. They used Photoshop, I think. They looked at the histogram and they were able to determine the pixel intensity, and then they could quantify that with a number. So they also took the pictures that they had. So say they had of each resolution, they lined it, or they had it at different light levels too. So they also were able to see if we get fingerprints that are really dark or really light, are we able to say that we have standard results across the board? And that since it was normalized, they were actually able to get consistent results across the board. So this is another way to help quantify and interpret the results and log them into a systems that make them distinguishable from other prints. All right. Fast and simple computer-aided internal electrical wiring project, design and integration of calculations. All right. That was the title. That's not why I used it. So essentially what this guy did was he looked at how electricians are putting wiring in houses right now. And they use a little bit of 3D CAD. Some do it all by hand, like you worked with architects. Then they have to figure out, okay, where do they run wires based upon how much electricity they're going to need in certain areas. They figure out, okay, well, if I'm going to put this fixture in my house, I want this much light here. I also want it spreading to this area. There's a lot of calculations that go in there based upon the wattage of bulbs, all this. So there's a lot of calculations that go there based upon the amount of power needed. So the goal was to use a 3D CAD software where he could actually calculate the power needed to all the areas automatically. Because what some difficulties were they were finding was the angle of the walls and then the allocation of the supplies. So using a 3D CAD software that had preloaded or presets in it where they could say put a light fixture, they could say, okay, this is what its rating is. We can enter that in. We can put that there. It'll be aiming this area. And then we can also say, what's the optimal way to wire this? And the program would do that automatically. So it did this by using a tree diagram. So it would also find if they ran a wire from on one wall, the program would also look at it and been there's an optimal route if you went through a different wall or if you merged with a different wire. So it's essentially finding the best way to wire a house and without using too many supplies and keeping the cost minimized. Another advantage of this was they're actually able to minimize the risks of miscalculations. So electrical fires, a lot of those happen due to electrician or someone putting in the wrong type of wire, wrong size. It's not rated for high enough wattage or current, and then it ends up starting a fire, or the wires rubbing together. There's a lot of different reasons, but there's miscalculation is minimized this way. So kind of a cool project. Multi-agent-based computer virus detection systems, abstracted from the dendritic cell algorithm. So essentially what they did was they looked at the human body's immune system and they modeled a computer virus detection system off of this. This article is really complex and over my head, but
hence the title.
Yep.
We talked about dissertation topics.
Yeah.
Yeah, those are good models.
yeah, it was very difficult. But what I gathered from it, I took anatomy and physiology my freshman year of college, so I had to go back a little bit. But essentially, breaking it down, they looked at the antigen agents, the dendritic agent, the T cell, and the responding agent, and they kind of modeled that over in the computer side. Now, also, you might be able to help me too, because like the T cell, is that the killer cell, the one that attacks? Okay.
White blood cells.
White. So essentially, is that correct? Okay. So essentially, it's modeling the same type of things the cells do within that. The antigen identifies it, and if that's right. Oh, non-destructive. Okay. All right. Okay. Help me. Okay. Well, anyway, like they were able to come up with a computer virus detection system that actually worked really well. The problem was with like the computer systems they had now is they had high rate of false positives and false negatives, and so like this, the nice thing about the human body is there's low false negatives and false positives. So that's where they're trying to model a system off of it. And the IT systems are getting larger and more complex, so they needed an adaptive defense system, sort of like what the human body has. So what that requires is constant communication between all these different agents. So they actually had these installed at different levels, one at the proxy server, with host computer, the SOC. All of these with like communication between each other to a lot of this was over my head, but like in order to adapt to it, essentially, they're using the adaptive algorithms that like you were talking about last week within the system. So it's kind of cool.
One thing, go back to that previous slide. So one interesting thing here that I guess stood out to me was I'm being a little targeted just because
that's fine.
Talking about this, I figured that was easier. But the low false positives and negatives for human immune systems is actually kind of an interesting thing because it is low, but it's not unfounded.
Nope, and it's not perfect.
Yeah, plenty of disorders like where your body attacks its own organs, and
that's the thing too. Like like when they're compare the computer systems compared to the human system, computers are like awful, but like the human's pretty good, but like nothing's perfect still. They know that they're probably never going to achieve 100% perfection there, but
well, that's where it gets interesting with artificial intelligence, though, because now you're like, okay, we are trying to mimic a system that we can't necessarily completely rely on.
Right. Yeah, that's kind of interesting.
Is it worth mimicking, or even a perfect mimic still isn't maybe good enough? Were they looking at applying this? I mean, so what's unclear to me is this. So they're creating an artificial immune system, but is it an artificial immune system that actually would be used in a person? Or
not in a person. No, this is a modeling of immune system. No, gotcha. But that's kind of interesting though too. Like
that's why I thought it was maybe looking at something like an AIDS or something like that.
Okay.
Somebody's immune system basically becomes non-functional. Now replacing it with an artificial one that, heck, even if it's half as good, it's better than nothing.
Yeah.
So
I might look into that though, see if there's like for one of the other topics, but nothing. I didn't see that within this article. They didn't talk.
Well, I think I mentioned something along these lines last week. I was talking about like cancer.
Yeah.
This stuff is really interesting. I don't understand that world enough, but just that concept is.
Yeah, I'd love to know more about that too. So this is just strictly modeling off of that. They had to change everything, but they looked at how the human body works, and they're like, okay, let's try and make a system that works like that. Okay.
Much safer.
Yeah, much safer. So this one was kind of neat. This one was a short article. It was on NFC commissioning. So like, there's so much that goes into like developing your smart house, like whether that be like installing a smart thermostat, like putting light fixtures up, but you have to enter in this product ID, you have to enter the passwords, get it all linked. Maybe it is a central hub. Companies are trying to make this better and better by like having it, okay, well, if you buy our device and you buy all of our other little things that connect to it, it's super easy, but you have to buy our device. Well, this current setup they were looking at was trying to make it so that you can use NFC, like say some from your phone. And that requires a transmission of like 3 to 10 centimeters. So like essentially if I have the setup on my phone, the app, I could take my phone to each device in my house and set it up quickly, like instantly screw in the light bulb, hold my phone up to it, it's done, it's paired. And then I have complete control over that. So that was kind of neat to see that, or no one, I don't know, I think that's growing. It's a growing field. I hadn't necessarily seen that in the store. Like you could buy something like that. It was kind of a neat area. It was also the security for it was pretty cool too, because you do have to be within 3 to 10 centimeters to pair with it. So no one's necessarily going to be like, if it's in your house, unless they break into your house, no one's going to be able to like get control of that, because they can use encrypted passcode that's like automatically generated. So it'd be a password that's like not something that you're going to make, but something that can be like extremely long from a computer. So like 128-bit encryption. I don't know exactly what they talked about in that, but it was very very interesting. So yeah. So for my topic, I think I'm going to look at maybe homes in general, because I kind of touched on 2 places there, like with the wiring. Whether I'm going to look at like the building of the home, as well as like the integration of like the smart home. Like how are the stuff that they're putting into a home or things like that, how is that making it actually more or simpler for the average user, or is that making more complex? I know like our topic was abstraction, but like you can also look at it the opposite way too, and saying like, are all these things that we're adding, is that really making it more complex, or is it making it simpler for the person to
Have you
actually?
done anything with smart home stuff in your?
I've seen some of the stuff. We're actually the behind Wittenberg, the hall I'm in charge of. We are putting an ice rink back there, and I bought a module so that it's like
Putting in an ice rink, like for the winter?
Yeah,
like specifically for the winter.
yeah, just only the winter. Yeah.
Okay.
Campuses or you are?
Well, I this campus,
We're gonna freeze the parking lot.
I got SGAs to fund it, so.
Are they gonna keep it when you're gone, or is it?
Oh, well, unless if no one puts it up, then no. But essentially, we're gonna have like light strands out there, and it's all run with like a module, one of those modules I was talking about, where you link it with one of their products. So we'll have an outdoor switch. So I'll have any of the RAs have passwords to this hub, and then they can actually turn on the lights for the ice rink. And then I can even like make it so that like I give you a password to that, but that password's only good for like 24 hours or something, and that changes or something like that. So.
Well, something you said that, so we have, a buddy of mine, he's a former student from here, Nick Largent. Do you know Nick Largent?
Nick Large.
I bet you I showed you.
Yeah, I probably recognize him.
You've been here long enough, you would definitely have seen him. But he's like a smart home freak. Okay, so I taught him how to program, and he's like taking this to the extreme. He works for NM now.
I think I might know who this is. Yeah.
So he has when I had my company, we had this like old vintage Pepsi machine.
Okay.
So he wanted the machine. I just wanted it out of my house. Okay. So he wanted the machine. So he took this like 1960s Pepsi machine and made it work with Alexa to dispense the right kind of soda.
That's sweet.
So he has videos up on his. So he thinks he's trying to automate everything. Even things just don't make sense to automate.
Yeah.
Right. Like so, he'll use Alexa from his car, so there's already a Coke waiting for him when he walks into his house instead of him having to physically push the button.
Oh my gosh.
Well, so that's kind of an extreme case. But like in our house, my wife wanted those smart lights.
Okay. Yep.
Yeah. So we have these Philips lights all over the house, and they can do different colors and stuff like that. You know how often we use colors that other than normal color?
Not very often.
Only the first week. Yeah. And just so you know, the color ones are way more expensive.
I believe that. Yeah.
And they come in a 3-pack, these lights, and most houses, if you didn't know, have more than 3 lights in them.
Yep.
Yeah, so we have something like, I don't know, maybe $3-4 grand in lights. The freaking house, it's stupid. But now, what's funny is that we've upgraded now for years, because you have to make sure your light switches are on. Mm-hmm. That way the thing works with the system.
Right.
So she put Post-it notes over the light switches, so we wouldn't accidentally hit the light switches, right? So for Christmas last year, I 3D printed her light switch covers.
Okay.
For that that allows you to get in there and flip it, but it strongly discourages you from doing it. So this looks a little more professional. So kind of getting along these lines is actually simplify life. Because I had to train myself to not use light switches because it's just too difficult, right?
Right.
I mean, why use a light switch when you don't have to? And if we have a network outage or something at the house, we can't turn the lights off.
Yeah.
Then I got to start debugging the network, and then I go over and like she might be in bed sleeping, and I'd go like whispering to Alexa, like, Alexa, turn off the bedroom
Well, no, yeah, that's really interesting because like your network goes. That was one thing I was really going to discuss. Is
So the
like,
bridge thing.
yeah, your network goes down. What do you do? Like you can't use your fridge now, or like you can't eat. I don't know. So
First world problem.
yeah, seriously though. So, yeah.
Like, I went to bed a half hour late because I couldn't get the lights off of the house.
Yeah.
And that's kind of what reminded me of that. Has it really simplified our life?
Right. That's what I'm interested in. Because
there are some aspects where when you're away, you can have lights come on and off and stuff. So there is some automation aspects to it that do make certain things easier.
Mm-hmm.
You know, like if you're out of town, you want to make your house look like it's being lived in. You know, lights come on, lights go off. You know, you used to have have these mechanical timers.
Yep, we have that. Yeah.
So certain things like that are better with something like that, but it seems like we're trying to solve problems that they don't need to be solved. Like, do we really need a picture of Yoda on our toast?
Yeah.
With Internet of Things toasters?
Yeah. Or even like, yeah, I guess like I've seen the fridges now that like they kind of take the picture of your inside of your fridge, and it'll know what you need from the store. Yeah, it'll give you a shopping list, and it'll like send it to your phone. But then that means you have to get the same food all the time. That also means you have to put your milk in the exact same spot every time. So like you have to be organized. So, and like I wouldn't like that. Yeah. I like put my milk in different places. So yeah, it's kind of cool.
Can I ask a question about your last one?
Yeah, absolutely.
When you said you have to sync it within like a certain amount of centimeters,
yeah,
that mean you can only like turn your lights on if you're
No. So that's just to set it up. Like that's because like these lights or the module I bought was like a switch. You had to enter in this ID code from the back of the little thing, and then you had to enter like some sort of passcode.
I know how those lights work. I just didn't know that one if you had to be like.
Right. So the whole idea was like, so say like if I take my phone and I put it up to the device, hold that, it does a link of the password. So now we're all set, and now it's automatically connected to my phone. So I can over the network or something like that.
So it's just easy setup.
Ease of setup, really. That was the whole idea behind it. Because I didn't really even talk about like if something went wrong or something like that, but the setup part was the whole idea. Yeah.
Did you notice that Amazon announced an Alexa for your car?
Really?
Yes. No, I didn't know how I lived without Alexa. I have like Android Drive in my car.
Yeah.
I have an Android phone based, so it's Apple CarPlay too. I like that because it's good for my maps, and then also it supports Audible, my audiobook player. So the two things I need, it works great for.
Yeah.
So, but the fact that I don't feel like I need to talk to my car.
No.
but you know, the thing is that, but maybe I do, because I already make all my phone calls now in the car with you know, I tell Google to, you know, call my mom or something like that. You know, I'm not pushing any buttons or dialing any numbers. So, you know, if Alexa can do even more, look up sports scores. So I can do sports scores now online, but you have to be going under a certain speed, otherwise it doesn't let you do basically real time browsing.
Oh, really?
Oh,
okay.
But you know, in any case, I just thought that was.
Well, it's interesting too because I took the Raspberry Pi computer and I made it into an Alexis because I just wanted to like see how it worked. But like I was like, oh, this is super cool. I'm gonna have it set up in my room. But like I like used it for the first week to show people, and then after that I like never used it other than to say, hey, what time is this?
I find at home it makes some sense. You know,
do you use yours?
My wife will ask, what's the current weather outside or something like that. You know, things like when you're putting your shoes on or something like that, and you just have a quick little fact that you want to grab from it. Yeah. Something like that.
Yeah. I guess I also don't know. It may have come a long way.
I don't think I'm ordering, you know, laundry detergent from Alexa.
Yeah, right.
You know, that type of thing.
Yeah. Doesn't it go off sometimes without you saying something? Because I heard it does do that sometimes.
I think we have not had that problem. It used to have that problem. I think early on, because there was a big thing. It was a funny thing on the news where some TV commercial was, or it was like a news program that was talking about Alexa, how you could use it to order goods, and they said, you know, like, hey Alexa, order such and such, and like 10,000 people's Alexas ordered something off of Amazon because it got triggered from the. So I think they made it now.
That's awesome.
I don't know if they make the commercials use like a different tone where we hear Alexa, but it actually isn't Alexa or something, or if there's something where the device itself filters out like the difference between a TV speaker and a human saying it. I'm not sure how they're pulling it off, but it doesn't seem to be an issue now.
Yeah.
I
I
haven't
heard
had it go off.
sometimes it has problems, like you could say something but not even call it and it'll still like reply back to you.
At the very least, we haven't had that issue. There is the only time I have that issue is I have one student whose name is Alexis.
Oh.
Okay, so and my wife knows her, so if I'm referencing her, that'll set Alexa off because I've mentioned Alexis.
Alexa's
Yeah,
pissed.
so that makes some sense. That those two are close.
Or how is yours like? Do you have to be in the same room to say it or to use it? Because like, or do you have to yell across? Hey Alexa.
Well, you don't have to be that close to it. We have them. We have I think 3 of them.
Okay, so
one
they're
in the
scattered.
bedroom, one like the main thing, and one upstairs.
Okay.
But yeah, and you can actually use it to broadcast. So it's like, if I'm downstairs, I don't want to have to walk over to the stairs to yell up to my wife up in her office. I can ask Alexa to broadcast a message to her.
Really?
Her
That's
Alexa
kinda
upstairs will go off. Yeah, ultimate. We're just getting lazy.
Yeah, that's kind of funny.
Ryan Brandon.
Oh yeah.
Had one in his thing, and all the RAs, when you did rounds, we walked past his room.
And just yell.
We haven't returned music back. He blamed his wife for like 2 weeks before he realized that it was all the RAs watching past his.
We do that. We do that with Josh Locklear.
That's hilarious.
Josh has an Alexa in his office.
No way.
So
I'm gonna do that.
Bob and I will walk by Josh's office. We've not in there, and we'll tell Alexa turn we'll tell to start playing some like bad music.
Yeah.
Funny. Yeah.
Well, I wonder also if it's like if you program your voice into it too, because now like Apple like Siri works with like only hearing my voice. Like I say,
I don't think Alexa's that way.
Yeah, and I don't think Alexa is. But I wonder if they're moving towards.
But it still has problems differentiating what you say sometimes.
I have not experienced that.
Like let's say if you had like an accent or something, and one day your voice is not
entirely
it
possible.
has problems.
One of my good friends is a British guy, and he has a lot of issues with not so much Alexa, but he has issues with Siri.
See, like
he
if he
doesn't
uses
understand.
American Siri, he has problems, but if he uses the UK one,
Yeah.
there's no problem.
But he still has problems with that. It's a very low voice. But he does use the UK one, and it's better. You're right. But yeah, so I guess I think my wife and our voices are plenty American.
Mm-hmm.
So we have not had any of those issues, but maybe for obvious reasons. But Dan, do you use Google Assistant?
No.
Can't imagine that being a real successful endeavor.
Try it.
Okay, Google.
You can get it started.
Okay, Google. Doesn't recognize you. Okay, Google.
All right, who's next?
Hey.
Who's next?
It'll work.
It worked.
This is the Fit Studio album by English rock.
That's good.
Okay, Google. Tell me a joke.
Which horse runs the city? The mayor, of course.
Google's got some serious bad.
I Bixby.
I'm on that computer real quick. Let me just download this presentation and get it set up.
I Bixby.
Hey Bixby.
I Bixby. I mean this. Hello Bixby, right?
Hello Bixby.
No, dude. Not that. How do you call it Bixby? Bixby, absolutely.
You just push the button.
No. You say it's some.
Oh, I don't use Bixby, but there's a button on the side. All right, it's all yours now.
Sorry, y'all, buddy.
See, there's a first world problem because you sent your presentation late. I had to remote from this machine into that machine to download your presentation, get it up.
It's convenient.
I almost had to get up. This one is what I'm saying. I mean, it was close. All right, go ahead.
So my first topic is source code bug prediction. So when a software is developed, there can be every developer wants to create a bug-free code, but it is not possible to test all kind of scenarios, all kind of components in a software. So there will be some kind of bugs in the code. So uh, I read a paper. This is actually a patent application. This talks about uh, using machine learning to predict the bugs in the source code. Right. So what this paper says is it follows a machine learning technique. What initially we will train the machine learning model. How we will train is we'll have a huge repository of the source code where we'll uh, uh, where we'll feed the this where we extract the patterns by comparing the source code having defects and source code without defects, and it compares the two things. So there are different patterns are extracted, like uh, one it extracts each and every source code lines and variables, methods. It does. There are different metrics, like character by character it compares. So there are different metrics it uses, and so by extracting the data, the feature matrix is generated. This matrix is in turn used to train our machine learning. Is given to the machine learning algorithms, which will generate a model for it. Later, this model can be used to predict the source code. Sorry, predict the bugs in subsequent source codes. So it gives the probability, like there is a visualization engine. It gives the probability, like this line has a probability of 20%, like 60%. It gives the probability of bug in that particular line. My next topic is brain-computer interface. Brain-computer interface can be used by the paralytic people who can't move their hands. So, say the people who have the robotic arms, they can control their arms with the help of brain control interface. In this paper, they have analyzed there is something called alpha brainwaves with the movement of our eyes, with the closure and open of the eyes, and movement of our eyes left and right. There is something called alpha brainwaves are created in the brain. So these waves allow the very low amplitude, like 100 to 200 microvolts. So they have used an amplifier to amplify the signals, and they use some filtration to get only the required frequency, like 8 to 12 hertz, I guess. In that frequency they get only those frequencies, and at the end these frequencies are passed to a microcontroller. And in this experiment, we have used Arduino microcontroller. What it does is this microcontroller in turn outputs to the robotic arm, some robotic arm or wheelchair or whatever the end device they have connected. So with just simple movement of eyes, they can control their arms. Like left movement of eye can be equal to the moving hand left towards left. A right movement of eye can move the arm towards right. That. And my next topic is head-mounted mobility.
Have you done stuff with those brain-computer interfaces before?
Yeah.
The BCI, have you done anything with these before?
No.
We have one in the department.
Oh.
Yeah, we have 14 input one.
14 input.
Yeah,
Okay.
so it's USB thing. So I mean, if you ever wanted to mess around with it or something,
Okay.
if that seemed interesting to you,
Okay.
it's laying under some papers on my desk in my office.
Like what it controls, like.
Well, I mean, you can program for it. There's an
Okay.
API, so it has. You put it on. It has 14 different.
Yeah, electrodes.
Yeah. And then you program for it. So, you're getting in that input, and then you can decide how you
Okay.
how you want to use it. What comes with it is like for a test case is they have like a computer software that allows you to like drive a car, like a kind of like a remote control car, where you think start or stop, turn left, turn right, and you train it. You train the neural network on thinking about moving,
Yeah.
and then you can
Okay.
drive the car by just using your own thoughts.
Okay.
It's kind of creepy. Yeah, remind me sometime. I just have to find the pad things for it. All of it's on my desk somewhere buried.
Okay.
But yeah, you can take it for a weekend or whatever, mess with it. And, yeah, it's pretty cool.
Another is head-mounted mobility for low vision people. Low vision people. So people have very low vision, low eye vision. Like not completely complete blind people, but people who have very low vision can use this some mounted display, mounted device in order to uh, see the environment, so that they can use it for the mobility. So when they put use this device, the camera inside inside the device will capture the surroundings, and it takes those images and it enhances those images with say it groups it takes only the required objects. It doesn't uh, consider uh, unnecessary things in that context. It takes only the useful object information, and it enhances the image with colors, so that the person can see the say he's walking on the road, he can exactly see the roads, path, pavements, cars, etc.
But that's not for the blind. That's
Not for the blind, not for the blind. It's
Poor
for the
vision.
poor vision.
Yeah.
People with the poor vision. So, so how this architecture works is when first the original image is given to the something called first the original image is taken and it is segmented. So like whatever the car boundaries, road boundaries, it takes it segments an image into multiple parts, and then it is given to the feature extraction stage. In that extraction stage, uh, it identifies what are the required, like what is the position, what is the shape, size of that a particular object. It takes it, it gives all, and then it is passed to something called neural network. So uh, uh, in this experiment they have classified into 8 objects. Whatever the kind of object you say, it will be classified into one of those 8 objects. Like any kind of vehicle will be just one vehicle, because the person needs to see that something is there. He does not need to know exactly what is there. And each of the object is given a different color. Like all the vehicles are given yellow color, road is black, each is given some particular color. And there is and this neural network has some database, so it gets trained like to identify, to group which given object into which end object. My next topic is home automation. This is a simple. This paper talks about creation of just simple home automation. What it needs is just a phone, a microcontroller. Phone has that automation app and the microcontroller, and the phone communicates with the microcontroller via Bluetooth. And that whenever we give some command, the app inside the app converts the voice command into a text, and it sends to the microcontroller. The controller is programmed uh, to give it to the correct relay. It outputs the relay board. That relay board will control the particular appliance. So my next topic is virtual reality and augmented reality in medical healthcare. So we can use combination of VR and in many applications in healthcare, like training a young doctor, as training a student, because uh, like they do autopsy. A medical student does autopsy. He needs to understand the human organs, like the position of various organs in the human body. So it is not practical to get a real human body every time, so that we can use VR, some VR simulations to 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 train the uh, young doctors. And we can also simulate the surgery. So before a doctor doing a new surgery, he can train himself with the VR surgery first, so that he does not do any errors in the real surgery, so that it reduces. And it can also be used. Medical staff can also use AR glasses. Like they can have that AR glasses can have face recognition technology. So whenever a patient comes, now the medical staff have to check their database to get the patient's records. So with these AR glasses, they can with the face recognition, they can directly get the augmentation of uh, patient record. And it can also be used for the distant medical learning, like a student learning how simulating a surgery, instead of we can they can have a distant learning, like both the teacher, the doctor and the student can wear some uh, AR device, and the student can start the surgery, simulate the surgery, and the doctor can see that, and he can provide his input. Yeah.
So which one are you focusing on for next week?
Source code bug prediction.
Which one?
Source code bug prediction.
Oh, okay.
I
What
want
interests
to.
you about that?
I want to see what is the current research in that, because I feel that is very difficult to achieve, because it's not because the bug depends on the context, that algorithm. It is very difficult. But I recently also have read that Facebook is also developing some kind of uh, tool like that for their project. So that is in the current research stage. So I'm seeing what is the
Yeah.
feasibility,
I mean,
how
I
effective.
think it's a good one. I don't know much about how it actually works.
Yeah.
Or even I think what kind of goes through my head is what's the purpose of it? You know, so we're thinking runtime bugs, correct?
Yeah, runtime bugs.
Yeah. I suppose it could be used in like quality assurance type of jobs to automate that type of job. So I just wonder if we could ever trust it as much as we could trust the person.
Yeah, but the developer has to cross check again. It will give some this probability of this line has a probability of say 60%, but
Well,
so
right.
the developer has to
idea would
cross
be
check.
that if you keep up that pattern for a while, where you have a human checking the prediction, and you update the prediction over and over and over again, eventually you get to the point where the humans aren't really having to fix stuff.
Yeah.
The humans
That is how machine learning
they're
works.
no longer necessary.
That is how machine learning works.
Okay. Yeah, I think that could be interesting. All right, next.
Okay.
So the first article I looked into was using immersive virtual reality for the treatment of fear of heights. And then they discussed the possibility of going into other phobias and fears, but also other just cognitive and mental disorders that they could treat that way. They discussed the idea of the low cost of it, because you could use like the consumer gear, and people can do it in their homes. They don't have to leave and whatever else. They can deliver direct coaching, so you don't have to. You can do multiple sessions with like one person, one therapist. That's the word I'm looking for. And then it also said that it's a good idea just because patients are more willing to not only address their fear, but try something to work against it, because they know it's not real. It's the simulated version of it.
Rip it off whenever they want.
Yeah. So they did it with a fear of heights. They did like a it's a struggle bus week, so I don't have time with the word. They had a group of like 100 people. 50 of them were the VR tested. 50 of them were the traditional treatment, which is basically come talk about your feelings, and we'll see how you feel about your fear of heights after. So they said compared to the traditional treatment, the VR was significantly better in improving the fear of heights. However, they didn't go into any of the technical information. They basically said, we're using VR, and hey, it worked, but they didn't say what type of VR they were using. They didn't say how they were implementing it. They basically said, we're just having a therapy session via VR, and it was great. So
Have you done anything with VR?
No, I get motion sickness very easily, so
That'd be good competition between the two of you. He can't get near a VR headset without you.
I mean, I wear C-bands just for driving.
My
so
wife is not that bad, but she's prone to motion sickness. But this hits, I wouldn't say I had a phobia of heights, but just generally, historically, if we would go up someplace high, I wasn't real comfortable.
Yeah.
And I do a lot of VR, and I've done all these, the things like there's a game that takes you to like face your fears. There's all sorts of things in VR that do that. Completely desensitized to heights. I can walk on a
That would be awesome.
1,000 feet up, no problem.
I've gone on the house on the rock, the
Mhm.
the overlook of it,
Yep.
and my knees buckled, and I had to crawl the rest of the way out because I couldn't walk.
Right. So I mean, so I've seen this happen. It's actually it's shocking. And then I'm working with a group. The collaboration. I think I mentioned it another day. It's a collaboration with the dean of the nursing school. Oh, actually, no, it's not this. This is a collaboration with Tracy Tuffy, from the psychology department, Lisa Lilligren, Christopher, opioid guy from pharmacy.
I know who you're talking about.
Okay, longish hair.
Yeah.
Cunningham, yeah, Chris Cunningham. And Dan Sem from business school, and we're working on a VR project that is towards opioid addiction, helping people overcome opioid addiction. So, this whole idea of applying virtual reality to things that you can't just get over with talk therapy.
Yeah.
It makes a lot of sense. I've experienced it myself, and it just is desensitizing you to the idea that heights are bad.
Yeah.
So yeah, I mean, it's very intriguing to me because it's a big part of what VR is currently being used for.
Mm-hmm. Yeah, I thought it was really cool. I just wish they would have put a little bit more techno in the article.
I can put you in one of our headsets that does the height thing because it might be fun to watch you collapse. But
I actually have a phobia of vomiting, so if I got motion sickness from the VR, I think that would cause more problems. I'm not sure if it would desensitize me. I think it might just set me off. I do have a fear of heights, so I will give you that. But I do have motion sickness
what exactly
problems
you're saying
too.
Are you saying that you're refusing to do it, or that we should have the cameras ready?
I'm refusing to do it.
Which of those two?
However, if I'm forced to do it, then you should have cameras ready.
All right, go ahead.
All right, I'll have camera ready.
Okay, my next one was using virtual reality to improve learning and retention of information for neuroanatomy and medical students. So kind of like the surgery aspect he was talking about before, they wanted to see that recently in medical schools, they have been cutting down on the 3D learning. So they've been cutting down on time with teachers and time with cadavers. So to learn the anatomy for certain things, it's really hard for people to grasp the concepts and retain it just using textbooks and the 2D models. So they actually have gone through the past couple of years and noticed diminished ability for the medical students who have graduated to perform in those areas. They actually go as far as to say that it's not up to safe practicing standards for the way that they remember neuroanatomy, which is your brain, if you don't know. So it's kind of important. So they wanted to see if VR would help them retain it. So again, they did the 50-50 split, except it wasn't 50-50, but half and half in a classroom setting. And they said it was effective, and they said it would be beneficial even in like a relearning thing. So like surgeons that are already out there, it'd be beneficial for them to kind of brush up on it using VR. But again, they didn't go into much information about it. However, it's I think it's a good idea. I think it could be beneficial, especially with the cut down on cadavers. I know my mom's an OT, and so she had to do a cadaver class in college, and she said that was one of the classes that she learned the most in, just because it was hands-on. So if you're a hands-on learner and you're only getting textbooks, that's not really beneficial to retaining information. This one went totally over my head. But it's a navigation system without GPS, and it uses a vision-based navigation based on the human eye. And for this, it's called R Advanced. That's this prototype in this article. And the huge benefit to their prototype is that it can go through different types of clutter. So indoor and outdoor, trees, buildings, urban, rural, inside warehouses, and then but from indoors to outdoors, it can transition well, and it adapts based on its surroundings, but it still works towards, there's like an end goal that it's working towards, so it's still working towards that, and it can go as fast as it possibly can through these areas of clutter. So it can go 19 meters per second, which is 42 miles per hour, which is pretty darn fast through a bunch of trees and stuff. But it'll kind of, again, adapt depending on where it is. A lot of it had every equation known to mankind in this article, and I couldn't even read the equations, and I was a math minor, so that's saying something. So I didn't include any of them because they were hurting my head. But yeah, it was interesting. They said that it could benefit agriculturally, to plant things. You could have it planted very quickly. You could have something sought out very quickly. Otherwise, they were talking about a personal delivery method using this prototype, where you could basically order something and stay in one spot, and that thing will find you wherever you are. So I interpreted it as like Jimmy John's. You can just stand there and they're gonna find me with a sandwich. So that was pretty cool. But otherwise, everything else went over my head. The next one is an intelligent multi-dose medication controller. In this study, they did it specifically for fever. So it's a device that they implement. It has two parts to it. There's a sensor that will sense body temperature, basically read your vitals and know when a patient should be getting a fever-reducing medication. The next part then will administer a dosage, depending on how bad the fever is, whatever else. And then the rest of the components of this controller will kind of read your body's reaction. So it'll go into the how much medication has reacted with your plasma. It will then work out kind of an output of if that dosage was actually helpful to you, depending on your symptoms. So if it was too small of a dosage, it'll correct itself for the next time. If it was too large of a dosage, again, it'll correct itself. So this is something that was somewhat difficult to follow, but it was enjoyable to read. I think it could be beneficial. They said it could be especially beneficial for those with chronic illnesses. So if you're taking 20 medications a day, it's really easy to mess up on a dose. It's really easy to miss a dose. For the elderly, it's really easy to do the same thing, you know. So it's kind of takes away some of that error with dosing. It takes away some error with contraindications of medications, and just is more automatic and learns and reacts with what your body's telling it that it needs. And then this is another VR one that I looked at. It was like the other two studies, so it didn't have a ton of information, but it went into the differences of 3 different types of VR. The cave, the HMD, and the desktop. So basically the cave, you're just surrounded by screens, and wherever you turn, it will react with where you're looking and give you the virtual reality that way. The HMD is just the goggles that everyone's pretty used to. And then the desktop is kind of like a video game. You know, you're just interacting with it using your keyboard and mouse. And it was going into the difference between the immersive versus the desktop VR in an education setting. So the other education I talked about just talked about straight VR. It was immersive. But this one's kind of going to see which one would be better suited for the education setting. It came out that immersive VR was significantly greater. However, I had some scientific issues with this paper because all of their participants had never used immersive virtual reality before. So it worked better for them, but part of their thing was that it kept their attention, it kept them motivated to learn, and I think part of that is just because it was new to them and it was cool and they were kind of really enjoying it. So I think as much as the immersive VR could be really useful in education settings, this study probably wasn't the best to definitively state that. But again, it could help with surgical settings, with medical settings. It could help younger kids if they're just visual learners, depending on what you're learning. I think it could be really beneficial.
One interesting thing with that last thing is, well, first of all, Marquette has a cave. They're pretty cool. For the educational setting things, I think you might be onto something there. I mean, I can see how an HMD might be good for education, but really a cave would probably make more sense depending on the experience you're doing. Because one of the things that a cave allows you to do is, like the one at Marquette, there's probably a seating area for maybe 20 people, something like that. And you all put on these stereographic glasses. It's not a headset; it's like normal glass, like you
like 3D glasses,
movie theaters for 3D movies. And then you're kind of surrounded by the cave thing. So for kind of group interactive experiences in VR, I would think education might make more sense in like a cave, minus cost of cave. But if their cave was something like $4.5 million or something like that, costly,
worth it.
But you know, the cool HMDs, you know, things like that, rips and stuff, these are just fun. So, you know, I think there is something to be said when you have a whole bunch of, what were the ages of the people doing it?
They actually did it in an undergrad setting.
Okay. I mean, that's like the perfect, you know, age group, where they're clingy to technology. You put something new and shiny in front of them, they're gonna
like the new and shiny. Yeah.
You know, minus, you know, some people with motion sickness or something like that, that it would have been a bad experience. But just in general, it probably wasn't great science. Yeah. From a real conclusions perspective.
Yeah, but I do agree that even the desktop version of just interacting with something. In high school, I did a sheep's brain dissection. I was sick for the week that it was going on in class, so I did it virtually online, and I learned more than half the people in my class who had the brain in their hands. So I enjoyed it. So I've never done the headset with it to see the difference, but I can imagine that any type of VR would be helpful in an education setting. I just don't think this study was a good one.
Good idea, not necessarily well executed.
So I wasn't really a fan of any of my articles. I found a ton that I liked the title of more, and they were all pay $40 to see the rest of the article, which I wasn't doing. So so I went with these ones. But I'm gonna look more into the smart device medication technology. And then if I stumble upon something else that piques my interest more, I might switch to that. But I'll start with looking into this.
Okay. We do. Yeah. I mean, it's not a super fancy one, but we do have a drone.
Yeah, the baby's
Just sits in a box. You can probably borrow it.
I'd love to. Where's that at?
In the
It is
server
that
room.
stuff there a bunch of.
No, this one's in the server room.
You have to put the deposit money on it.
You just have to.
I'll go with it.
Yeah, that I'd rather somebody mess with that VCI, so it's not just sitting on my.
Well, that's
sitting
I'm thinking-
near my desk, on my desk. Oh my
I'm
God.
thinking both of those together. That'd be cool.
No. I think that would be really cool.
That'd be sick. Oh, it's actually you have to deposit some money to the brain. No.
All right, go ahead.
Some articles all relate to self-driving cars. The first article, it talks about like the key like components that make up self-driving cars that we depend on, which are car navigation system, path planning, and environmental perception and car control. And in this article, they were explaining that we should like have people understand like how each component work in a self-driving car, so we can eliminate like human problems with like dealing with security and social and ethical issues. So and law problems like license problems and driving regulations and responsibility and information security. So we can eliminate, because if there are problems from these with the laws and the human like how society sees it, it doesn't allow us to be able to like, with people not understanding like the idea, and like with these are restricting the development of like self-driving cars. And in the article they explain that we should educate people on this and try to have more laws that allow us to improve on the technology, because of issues that people see today happening that's limiting the growth of the field. And the next article, these people are trying to like develop a solar energy powered solar power energy self-driving car, and they have a like, this is like a basic design of how they want their system to be designed. And the system would be able to calculate reaction time and to be able to overtake cars and stuff like that. And with this local algorithm, it tells the car what speed to drive at and when to switch lanes and stuff like that. And their goal for this, for developing this type of self-driving car, is to eliminate like accident and traffic buildup, and help reduce pollution that's being emitted to the atmosphere. And then my third article was about the ethical and social aspects of driving cars, and they were talking about how problems of ethical and social problems are due to the decision makings that are being done by these systems to solve a problem, which are called trolley problems. And that and the article talks about the different types of ethical and social principles that when engineers build these systems to consider when developing self-driving cars, so it could eliminate the problems that are being presented by the decision making in self-driving cars. And the next article, it talks about like it's like this article's from like people that did research at Apple on like self-driving cars, and then their idea was they were talking about like how there are like detection systems that we have that uses like LiDAR, which is a 3-point cloud detection system that detects like 3D objects. But they talk about like how those systems they don't work that well because they're not able to detect certain like all objects in its view and stuff. And then they proposed that people should use their use of Volnex, which is a it's developed by Apple and they built on the LiDAR base 3D point cloud. But in their system, this system is able to detect all objects and stuff, and they ran many tests that they ran many tests using this system, and it turned out it was a better detection system than the other systems used in self-driving cars. And then my last article, it's about how these people are trying to figure out ways to be able to teach the system to learn from errors that it would detect. And like these two types of errors that the system detect would be like a temporal cue, which like the error occurred like would show up because of like the detector had problems detecting an object that was moving, and then it would fix it by using a multi-object tracker to like estimate the location of the object that's moving and stuff. And the other error detector would be a stereo cue, where like errors would occur when images they look alike, and they would fix that by using this hereditary map detection from one image to another. And when they were able to do that, but they were not able to successfully make their project work because of problems with the system not being able to detect all objects and stuff, which uses the LiDAR-based detection, 3D detection thing, and yeah. And then for next week, I was gonna focus on looking more into like the issues with detecting objects and try to figure out what's the problem and solutions to it, and why we need to fix it because of events like Uber and stuff, where like cars were getting into accidents and stuff or killing people. It's like slowing the growth of a self-driving car, and this problem needs to be fixed because we got to make it safer for people so they don't get hurt and stuff like that, and also help decrease pollution and increase traffic flow if we're able to develop like improve on the technology stuff for the future. That's it.
One thing you might want to focus on as you go through this stuff is, I mean, you mentioned this idea of LiDAR. If you look into Tesla's approach to self-driving, one of the things is you're going to see them claim that everything can be done with just cameras, not using other technologies. You mentioned some of the weaknesses with LiDAR. If you look at some companies, I know Chevy's doing this. I want to say, well, I know Chevy's doing it at the very least. They believe that the Google self-driving stuff is also doing this. That LiDAR is part of the solution, not
All companies are doing it.
yeah, except that Tesla. Yeah.
I mean, the problem with it is because it's like I just told you, it's not able to detect like all objects.
That's why they're using other systems along with LiDAR. So there's certain things that LiDAR is really good at. There's other things LiDAR isn't as good at, but there's other technologies that are good at those things that LiDAR is weak at. So one of the things that I think you're going to find as you look into this more is that there are 2 or 3 or 4 kind of complementary technologies that fill out the weaknesses of the ones around it. Where the approach of Tesla, which I have to think that they're too far down the rabbit hole to back out at this point. They've gone all cameras, thinking that you can solve it that way, and maybe they'll prove that they can. But it seems like, as you mentioned, everybody else is saying cameras might be good, but there's also, weather conditions, things like that might make some cameras not good. So we need some other technologies to complement, computerized vision. So I think LiDAR is an important piece of that puzzle, but I think you're going to not find that LiDAR is not part of the puzzle.
I'm not saying it's the problem, but that it does work. But like how I was telling you in that Apple research article, that it works, but it's not able to detect as many compared to their how they added on to their software onto of that.
Okay.
Like they made a better version of that basically compared to others.
Yeah, I get it. So not trying to solve the whole self-driving car problem so much as saying, okay, LiDAR is a part of self-driving vehicles, but here's an improved version or an improved take on LiDAR using a software layer.
Yeah.
Okay. Yeah, I like that.
And then the last article I was talking about, how they were trying to since most of the cars that are that drive by themselves use detectors, to be able to have a constraint where it does detect an error, it detects that it's an object, but I just wanted to figure out if there's ways that you can warn the person if it doesn't understand what's going on, or just stop the car somewhere safe and try to they're talking about how they could also they're based the Apple one, they're trying to have the system learn too as it goes, because LiDAR, it's built on a prefix rules that we give it constraints, right? But in the Apple one, it's able to learn and change the rules and set it as the new prefix and stuff like that. Yeah.
I got that. Yeah, that's the piece I was missing. Is it's an enhanced.
Yeah, I'm sorry, I forgot to mention that.
No, I think you did. I was just, my mind was going in this other direction. I think you explained it correctly. I just didn't hear it the way I needed to hear it, because I was already thinking down and around the corner. All right, yeah, that makes sense. I think that's a good thing to look at. I don't know a lot about that. Good. All right. So now I'm sending an email to everybody right now. I think I mentioned it maybe our first day of class, but I leave for India for 2 weeks next Thursday night. So we won't have in-person class next week or the 4th or the 11th. But we're still going to have our same assignments. The only thing that'll be different is we're not going to meet in person, but what I'll have each of you do is do a screen capture of you giving your presentation on your laptop and upload it to YouTube. Send me the video and also post the video link. Here, I'll get submitted this email.
So we don't have to watch the person's video.
Huh?
We don't have to watch the person's video.
Well, I would encourage.
I'm just saying.
I can't force you to watch the videos, but if one of the goals of the class is to learn about these different things, you should watch your classmates' videos. I will be watching all the videos. So email me the videos, but also post them on the Slack channel.
I thought you would have wanted us to do a live video presentation that we would have to watch online. It tells you how many people are viewing it.
Yeah, but and the thing is I thought about doing class live. I just don't know how much I can rely on India hotel internet.
Yeah.
So
if you live that,
but that's only 1 day a week. For so that wouldn't have been the end of the world, just to keep things rolling. But
you have to make the video what a classmate video and separate what classmate did up.
Do an annotated bibliography of all your classmates' videos.
Yeah.
No, so I will watch all the videos and provide feedback. I encourage all of you to watch each other's videos as well, but I'm not going to be quizzing you on it or anything like that. So just instead of coming to class next week, make sure you submit all your stuff and then upload a to YouTube and give me a link to your
So
video.
when you get back, do we have the midterm then, or?
See, that will be
The
week.
week you get back is like fall break for undergrad, I believe.
Yeah.
So
So
we still have class.
well, let me see.
Not that I'm trying to get off, last year isn't doing it because he had.
Yeah, typically we would not meet for fall break for undergrad. Let's see. So next week's the 27th. Then the 4th. So I'm back on the 11th, but in the evening. So you're saying that fall break is that next week?
Yeah.
Let me double check that.
I'm missing the other.
Well, if it is fall break, I'll cancel. I can't go and take a 2-week trip to India, then come back and punish you for not showing up to class. It's not a vacation. We're recruiting for the grad programs, and it just so happens that we have to go when they're in session for school, which happens to be during when we're in session. But let me.
Sounds fun.
It's going to be interesting. I get all sorts of different impressions of what India is going to be like.
A lot of scorpion.
No, I don't see anything about scorpions. Wild monkeys,
No, not in cities.
It's
Not
the
the
cows.
snake,
It's the
dogs,
cows.
Dogs, yeah.
definitely dogs.
Cows.
Alright.
There's a lot of cows that walk around.
Yeah, there are cows, but they don't bother anybody.
Yeah, they don't bother anyone.
Oh, there's one video where the cow just kicks some lady.
They're not holy.
They're not holy.
They're not holy. The cow not holy.
Holy cow.
No, the cow not holy.
Let's see. Traditional.
It's probably cleaner than China, though.
No.
No. You heard that?
You're basically saying that India is dirty.
Yes.
That is true.
Really?
Yeah. That's true. Yeah.
Vietnam's
No,
pretty
no.
dirty too, dude.
What?
Vietnam's pretty dirty too.
Is it really?
I don't know Vietnam, but
Give me a proof, you dude. 10 years you didn't get back to Vietnam.
You're saying-
compare, man.
So you're saying Vietnam's not dirty?
Isn't it a serious opinion? It's not dirty.
Yeah. I think every country has their nice spots. Every country has their.
I mean, accept it.
Let's not let this get on the news
We're
spots.
talking about health-wise, it's not that good.
Well, I accept that people peeing on the road. When they get
People do that
drunk,
here too.
And then people are the
When you get
doctors.
drunk,
The doctors
the
they
wall.
diagnose you with the wrong symptoms because they paid to get that degree. So it's pretty bad. Some guy they took his kidney without him knowing, and he came back to the States, and then he was like, the doctor's like, you're missing a kidney.
Ahmedabad and Chennai. There's some cities in between.
Just can't drink.
All right, so this is what's gonna happen. So I'm gone. I'm gone the 27th.
Right.
I'm gone the 4th. I'm gone the 11th. Fall break is the 18th and the 19th, which is the next week. So what I'll do is I'll get the details out sometime before the 11th
So it
for
should
what
be-
that midterm assignment's going to be.
Okay.
And then what I'll do is, so we won't meet on the 18th. The midterm assignment will be due on the 25th, but you'll have the details for it before the 11th. So you'll have 2 weeks to work on that.
Sweet.
Oh, so we get to work at home.
Yeah. It was an at-home thing anyway.
Okay.
So it was originally going to be a 1-week thing. So I'll give you 2 weeks. You manage your schedule however you want to do it. Since we won't meet on the 18th, which is fall break, but we'll come back and you'll do your presentations related to the midterm on the 25th. That sound fair?
Does that also include the one from before too?
One from before too. What one from before?
Because that week that we missed, basically, we should have.
No. There won't. You won't. That assignment won't exist for that week. We'll pick up. We'll
After
start
we finish,
fresh.
then we'll
Yeah.
start. Okay.
So for next week, so for the 27th, you are sending me a link to your presentation for the for your thing for this. For the 4th, that's your annotated bibliography for the next thing. Yeah. For the 11th, that's your final presentation for the 11th. That takes us through an entire. We're done with a great idea, right? Then for the 25th will be the midterm project, which I'll put the details out for. You'll have 2 weeks to work on that, even though it's meant to be a 1 week. A 1 week.
So
thing.
for the third idea, is it still abstract?
No.
I saw it on there. It's
Data.
abstract.
Data and information.
Data and information.
Okay. Because I'm pretty sure on the.
I'll double check that. I'll double check the slides. Let me check. But does that make sense?
Yeah.
What's happening?
It goes to the next year.
So you'll have, if you want to take that whole week off for fall break, that's your prerogative, because the midterm is a 1 week assignment. But I'm giving you 2 or more weeks to work on it, because I'll probably get the details up as soon as I can.
So basically, we meet at the end of
25th.
September.
October. Last, the 25th is
October,
the next time we'll meet in person is on the 25th.
Gotcha.
Okay, does that make sense? That sound fair to everybody?
Sounds good to me.
That's a date like
Right. Oh, well, let me actually clarify though. Shoddy, you have to be here on the 18th.
Oh, I'll be here.
All right, so questions, comments, concerns, bribes? So when you record your presentations, what I would suggest you do is do a screen capture of have your presentation running on your laptop. Do a video screen capture of that. You don't have to do a screen capture of you. I'd rather see the presentation and hear your voice. That's going to be a lot more readable. So
do it on my face.
You don't register for next semester?
Remember top line on YouTube?
Yeah, so put it on YouTube. If you want, you can make it a private video, but set it so anybody who has the link can see it. I don't care if you make it private. Just make sure I can view it and your classmates can view it if they choose to view it.
Famous.
What were you asking?
Oh, do you know when we can register for next semester?
Whatever.
You can do it now.
I think you registered already. Yeah.
Unless you have something
Oh,
like
okay.
I did.
Still on page for this.
Yeah, I think you can register whatever. What class is that? Is 518 next?
That's what you said, right?
That's the programming one. Oh man, this is a nightmare. You guys have been pining for all this reading and presentation.
Well,
All right.
possibly all in VR, right?
Huh?
The 518.
I don't know. I'll have to see what the current trend is. I mean, it might involve VR, but it won't be the same as last time. It'll be a different twist, something that's up to whatever the current cool stuff is. Maybe it'll even be augmented reality.
Oh.
We'll have to see what the current cool kid is. Oy, oy.